What is the set of points equidistant from the lines y equal to 5 and x equal to minus 4? Okay. So again, let's just see what these lines are. So this is the coordinate plane. Y equal to 5 will be here, x equal to minus 4 will be here. So essentially we are talking about somewhere on this space, right? So y equal to 5, this is x-axis, this is y-axis, this is x equal to minus 4. What is the set of points that are equidistant from the lines y equal to 5 and x? So this is one line, this is one line, and this is the other line. We need to find out points that are equidistant from it, right? Now clearly, if you visually see only, right, that if you take a random point, let's say here, so it's closer to this line than it is from this, so out of convention. Similarly, if you take some point here, it is closer to this than to that. Similarly on either side. So the concept that you need to remember here is for any two lines, and this is true for any two lines, if you need to find the set of points equidistant, the points equidistant from the two lines will always lie along the angle bisector. Let me repeat that. The points equidistant from two lines will always lie along their angle bisector. So even if you have like these two lines, right? If you are asked to find the set of points that are equidistant from both M and N, all of those points will lie along the angle bisector of this. Each point, if this is the angle bisector, basically, it's the line R, each point on this line R will be equidistant from both of these lines. Okay, so with that known, there is another way to figure this out, even like not knowing that, but yeah, like added this question just so that can cover this concept of points being equidistant from two lines. So you should immediately strike that this should lie along the angle bisector of those two lines. Now this helps me a lot. Why? Because like this is one line, right? This is the second line. So basically this will, this and this essentially, right? So this will be the angle bisector, something around this. This is obviously 90. These lines are like one is like parallel to the y-axis, one is parallel to the x-axis. So obviously the angle would be 90. So which means this is 45. I know this point. This is the meeting point of x equal to minus 4 and y equal to 5. So this point is nothing but minus 4 comma 5. A simple intersection of these two lines, right? This is, each of these is 45 degrees. This is 45 degrees. This I know is 90. This will also be 45 then. This is 135. This is 45. This is 90. So this will be 45. So this will be 135. I know one point. I know the angle it makes with the positive x-axis. I'm done. Why? Because this is the angle with the positive x-axis, right? So the slope of this angle bisector line, and again this is the angle bisector because each point on this line will be equidistant from this, and that is what we need to find. What is the point equidistant? As we saw that for any two lines it will lie on the angle bisector. So the slope of this angle bisector is nothing but tan 135, which is minus 1. I know a point minus 4, 5. Let me directly write the equation then. Y minus 5, x plus 4 will be equal to minus 1. So y minus 5 is minus x minus 4. So basically say x plus 4 equal to 1. That's the answer to this. This is x plus y equal to 1, and that is the set of points which is equidistant. So every point on x plus y equal to 1 will be equidistant from these two lines. One concept we already saw. The second concept was only that, okay, you have to take the tan of this angle and not the 45 one because the positive x-axis is to be taken. Find the shortest distance immediately, even before like putting pen to paper. We know that shortest distance will be the perpendicular distance, right? Irrespective of what the graph is, even if it was something like weird, like a parabola, hyperbola, or whatever, the shortest distance is always perpendicular distance of this point from this curve. So I need to first figure out what this curve looks like. Correct. There are two modes here. So let's just try to figure out what this curve looks like in the first place. So there are two critical points here, right? 1 and minus 1. And even in questions of functions, you know, when we like you will discuss like modes in more detail, everything revolves around these critical points. So here there are two of them, which is minus 1 from here. Like x plus 1 gives you this critical point of minus 1. X minus 1 gives you the critical point of 1. So there are two critical points. Essentially, there are three regions that we need to study, which is this one, and this one. So x is less than minus 1, X between -1 and 1, x greater than 1. So let's just see that what the equations look like for those three cases. If x is let's start with, let's say, less than -1. If x is less than -1, this quantity of x minus 1 will become 1 minus x. And no need to get confused. Let's take any value. Let's take -3. So what will -3 give? -3 minus 1 -4, which is a negative number. And whenever we get a negative, we reverse it again. Mod t is t when t is positive, mod t is minus t when t is negative. So we have to take the negative of this, so which is 1 minus x. X plus 1, similar. You, like, whenever you take the value less than -1, let's say you take -5, right? So it will be -5 plus 1, which is -4, also negative. So this entire thing will become negative of x plus 1. So minus x minus 1. This entire thing will become minus x minus 1 since a negative will get added here. Okay, so what does this give me really? Y equal to -2x. So I know that if x is less than -1, y should be equal to -2x. If x is between -1 and 1, and again you can put the equality sign, as we mentioned that the functions are continuous, so it won't break. If it is between this, then what is the equation? So x is greater than -1. So let's say x is -0.5. So -0.5 minus 1, it's still a negative number. You still have to take 1 minus x, plus -0.5 plus 1. This is a positive number, so you can take it as it is because it is giving a positive result. So what will this give me? Y equal to 2 for this. So this, basically this, and this will basically this. The third region is nothing but x greater than 1. Y would be what? X greater than 1. Obviously x minus 1 would be a positive number, so no need to worry here. X plus 1 will also be a positive number, so no need to worry here. So it is just be 2x. So now for every interval of x, we have an equation. So what will be the graph like basically? And again, explaining it takes a bit of time, but essentially this is pretty simple, right? Like you just plot the critical points here. Just take the ranges, just take some sample value. Like if you're not able to check it directly, just take some sample value, and it will tell you that whether this has to be taken or the negative of this has to be taken. There's only two scenarios: whether this is taken or the negative of this is taken. For example, here we put the -x -1 thing in this case. So x less than -1. So let's just write -1, 0 and 1, 0. So for x less than -1, the graph will be -2x. How do we plot -2x here? It will obviously pass through the origin, right? Let's just plot y equal to -2x. So for x equal to, let's say you take any random points, like x equal to 1, y will be -2. So 1 comma -2 should be here. So it will be something like this shape. Like it will go, like it will cross the origin and like go there and stuff, but we only need it for the x less than -1 range. This is important. So we only need it for this part of the graph because x is less than -1 here. So we know this now. Between these two, it's simple, y equal to 2. So between these two, it will be a simple line like this, straight line. And this will be 0, 2. And please keep marking the coordinates as and when you keep figuring them out. Otherwise, if you like keep it for the end, you start getting confused as to what point was what. This is origin, this is x-axis, this is y-axis. So this is 0, 2. From y equal to 2, between these two lines, simple straight line. For x greater than 1, it is y equal to 2x. So y equal to 2x is nothing but like if we draw the full line again, it would be something like this. But since we only need it for the greater than x equal to 1 portion, so it will be something like this. So this sort of a bathtub type of a shape is our graph. Cool. So this is the graph essentially. So you basically took critical points and then you sort of just plotted for each of the ranges and made the graph. Okay. Find the shortest distance of the point, 0.5, 1. Now this is 0, 2. So this is at a height of 2 units, right? This point is 1, 0. So this is the sort of a distance of 1 from origin. Now I need a point of 0.5, 1. So it will be somewhere here, like half and then 1, height of 1, somewhere here. So what will be the shortest distance? Obviously this will be the shortest distance. So directly 2 minus 1 is 1. Like this was at a height 2. This point 0.5, 1 is at a height 1. So the shortest distance would be what? This one. The remaining, which is 2 minus 1 is 1. That is the answer. And this was a CAT 2017 question. So again, no, like as such, no arithmetic working required here as such. It's just a plain graph plotting question. Lines x plus 5 minus 4 equal to 0, x plus 5 plus 8 equal to 0, minus x plus 5 plus 4 equal to 0. Form three sides of a square, find the fourth side. Already given it's a square, right? Also, some other things are already given, but you need to find them out immediately when you see that. X plus 5 minus 4 equal to 0, which is basically x plus 5 equal to 4. X plus 5 equal to minus 8. These two lines are parallel. X plus 5 plus something, x plus 5 plus something. These two lines are parallel. So two parallel sides of a square we know. Minus x plus 5 plus 4 equal to 0. Now, obviously, this because it's a square, so it will be perpendicular. Even like you can check that the slope of this, what will be the slope of this? Minus of x coefficient over y coefficient minus 1. What is the slope of this? Minus of x coefficient over coefficient. So minus of minus 1 by 1, so 1. The product of this is minus 1. So which is perpendicular, right? Which it should be. If it's a square, then if these two are parallel sides, so if these two are parallel sides, this should be the third side that is given should be perpendicular to them. Right. In the previous question that we have seen, you needed to find the vertex, fourth vertex basically, where we said that okay, the diagonal bisect each other, so the fourth vertex will be this as per midpoint formula. But here you need to find the fourth side of the square. What is the quickest way to do it? One quick way I can think of is, yeah, please go ahead. Somebody was saying.
Yeah, assume one vertex at the origin.
So let's say this is 0, comma 0. This is a square. And then basically you will solve for the points and then find the equation on the fourth side, correct? So like you know the equations, you assume one as the origin, then you basically solve those two lines and get this point, solve these two lines, get this point, etc. You can find the fourth side. Absolutely correct approach, although that might take some time. The sort of the oral approach to this could be, if you observe carefully, like as you see, right, that these are parallel lines. Clearly these are separated by, like if you write this as separately, x plus and x plus y equal to minus 8, there is a gap of 12 units here. Like the actual distance would be 12 by root 2, because distance between parallel lines is like c1 minus c2 over root of 1 square plus 1 square. So actually would be 12 minus root 2, but for sake of conversation, right, these are, everything is the same, these are just coefficients are 12 apart. So basically this would be corresponding to 12. Now I should ensure that the other sides also have a difference of 12, because it's a square, right? So the side will be equal only. So this would be 12, this is corresponding to 12, this will also be corresponding to 12. Or like in technical terms, it should be 12 by root 2. But yeah, essentially, like from a visual perspective, I know that okay, there is a difference of 12 here. So technically there should be a difference of 12 between this and the other side. Right? So minus x plus y plus 4 equal to 0. The fourth side should have a gap of 12 with respect to this line, so that the distances remain 12, or 12 by root 2 if you want to be accurate. But yeah, what will that line be? That line could be minus x plus y plus 16 equal to 0. But also that line could also be minus x plus y minus 8 equal to 0. If you want to check, you can obviously check that what is the distance between these two lines? 12 over root 2. What is the difference between this and this line? 12 over root 2. But it's important to realize that there are two squares possible.
Sir, can you please explain it again?
Sure, sure. Absolutely. I know, let me just write these two equations separately. X plus 4, x plus y equal to 4, x plus y equal to minus 8. I know these two lines are parallel. So let's say these represent like these two lines, or these two lines. It really doesn't matter. But these are parallel lines. Separated by 12. This is 4, this is minus 8. Separated by 12 units. Or if you want to calculate the distance, it's separated by 12 upon root 2. Basically, because c1 minus c2 over root of a square plus b square. So here a and b is 1. But essentially from an equation standpoint, I know that okay, if x plus y equal to 4 and x plus y equal to minus 8, so from a graphical standpoint, they are like sort of 8, like 12 apart, right, in a way. Now, if this is a square, and I know that the sides of a square are equal, which I do, so the gap between the other two sides should also be 12. So the fourth side should also be parallel to this and at a gap of 12 from this. Like these two are parallel and had a gap of 12. The fourth side should be parallel to this and have a gap of 12. So the fourth side should be minus x plus y. This much I know because it's parallel. Gap of 12 means this should either be 16, so that there's a gap of 12, or it should be minus 8. That is again a gap of 12. So there are two squares possible, essentially. And that is what this problem is about, that you can create two squares out of these. So good question, like in the sense of like it's very basic only, but the only thing is, yeah, there's a quicker way to do if you just realize that, okay, you'll hit the fact that it's parallel lines, obviously, because you'll see the equation and you'll get it. You'll also hit the fact that these are perpendicular. Even if you don't hit it, like there is a condition of a square, so it has to be perpendicular. After that, the distance between the parallel lines is, let's say, 12 by root 2. So you need to ensure that, okay, if there is a jump of 12 here, there should be a jump of 12 here. And you can check the distances again. For example, if you check the distance of this point with this point, it will again be 12 by root 2. These coefficients are not changing, right? So the root 2 will still be root 2. So the last question now, which is a CAT 2019 question. And trust me, the length of the question is actually more than the length of the answer. Let T be the triangle formed as a straight line, this on the coordinate axis. So once again, have to figure out 3x plus 5y is equal to 45 is the line. To plot this line again, just refer to the x and y intercept. X intercept will be 15, 0, y intercept will be 0, 9. Join this line, you get the triangle. Let the circumcircle of T have radius L. So this is the triangle T. Then the circumcircle will be existing. L measured in the same unit as the coordinate axis, integer close to L is what? Right. Let the circumcircle of T have radius L. So basically we are asked L, which is the circumradius. Now, if somebody is in a hurry, what they might do is, okay, circumradius it's fine. Why don't I just calculate the length of the three sides, divide by 4 times the area, and I'm basically getting the circumradius, which is what is asked, which will again give you a correct answer. But is that the optimal way? No. We know that for a right triangle, the circumradius is half of the hypotenuse. This, all three are equal. This is x, half of the hypotenuse. This is also a right triangle because it is formed with this line on the x and the y axis. So if I can just find out the hypotenuse, the half of that hypotenuse would be my circumradius. Question is done. So this, what is this length? 0, 9 and 15, 0. So distance formula, it will be 15 square plus 9 square, which is 225 and 81, which is 306. So my L would be root 306 by 2. This is my L. I am asked what? Integer closest to L. Now I know that 17 square is 289, 18 square is 324. So this will be 17 point something, I don't know what, by 2. But this will clearly be somewhere between 8.5 and 9, right? Because 17 itself is 8.5 and 18 would have been 9. So this number would be somewhere between 8.5 to 9. In either case, the integer closest to L will be 9. So that is the answer, 9. That's it. Simple distance formula question, nothing else. And this was a CAT 2019 question. Cool. So only additional thing that you needed to know, and in fact, even without that, it would have just taken more time, but you would have gotten to the answer. You would have gotten to the outcome. But like just the fact that the circumradius is half of the hypotenuse for a right triangle is more than sufficient to wind this up in like 15-20 seconds. Once you have drawn this line, which you can quickly draw by, as we had discussed, that just mark the intercept and join this line. It's a bit over time, but yeah, like just wanted to like cover the things and the like some of the questions. If we like again, whatever we have done like today, if we just go over those questions once, this was still for the previous sessions. So here this question was a good application to see that you don't need to always be given coordinates in order to realize that it's a coordinate geometry question. You if you see like some easy to handle figures, you can assign coordinates and assign the length as per those what is given in the question, and you can use the typical coordinate functions that we have. Even if, like, let's say you had this rectangle, right, and we have a similar figure as we discussed, and you were asked, or like even a more complex figure, and something like this, you were asked, okay, what is the ratio, like what is this by this, or basically this over this, or what is the ratio? You can use distance formula, section formula, etc. Everything, if you are able to assign the coordinates as per what is given in the question. So sort of saves time on some of the questions. Okay, so this was that, and we also like covered one additional property of triangle, which is this one, the square plus b square, which is 5c square for the perpendicular median specifically scenario. Next was coordinates of photo perpendicular. You know this line, you know the slope of the perpendicular can be found out. You know one point, you know the slope over. You can find the equation of this line, and the intersection point with the existing line would give you the foot of the perpendicular. 3 vertices, 4 vertices just diagonals bisecting each other. And again, after ensuring that the vertices are in order, like are in some sequence. They can be in any sequence, but they should be like in one. So by any sequence, I meant that basically they could be in a clockwise or anti-clockwise, doesn't matter, but yeah, they should be like sequentially. Here, this was a cat question, again, just based on the fact that you just find the midpoint of a diagonal, put the coordinates on this equation. Why? Because this midpoint will again lie on this given on BD, and you just find C from there. Area of quadrilateral, you sketch the quadrilateral, the area, you find the vertices. Most of them you would know from like assigning vertices, and the one that you didn't know was found by solving this line and this line. Then the area of the quadrilateral. Modulus question, you should ideally know how the mod graphs work, especially like if there's only one mod. For 2 or 3 mods, you can obviously do the algebraic way in which we did the other question, but for one mod, yes, helpful to know the shape. So it will be a different equation here, different equation here. This equation created this point. We knew the other points, found the area of this using trapezium, or the area of the quadrilateral formula could have also been used. Set of point equidistant lies on angle bisector. We have covered this concept, and after that, it's just basically taking the slope of this line. You know one point, you know the slope. You can find the equation of the line. Shortest distance we covered is always the perpendicular distance, and half one, and you basically took all the ranges, made this bar chart type sort of a diagram. You saw where the point is, just observe where the point is. You saw that it's at a distance of 1 from here. This is a distance of 2, so the shortest distance will be 1. 3 sides of a square, find the 4 sides. Again, just identifying that which lines are parallel and what is like sort of what the jump is between those lines. So similar jump will be on the 2 other lines as well, and the distance between them would be the formula that we already studied, the jump upon the root over a square plus b square. So in this case, it was 4 plus 8 over root 1 square plus 1 square. So the 4th side, and again, the important point is that there will be 2 cases here. Yes. See with a triangle formed by straight lines, and this again is just the right triangle property. So here. So again, the set of formulas itself is pretty simple, but there are some like additional things that you need to keep in mind, as we had mentioned even in theoretical section, that let's say if you are given a line and you're given like a distance of 10 units, and you're supposed to find out which point lies at a distance of 10 units. So always remember that there is a mod in that formula. So you'll have to equate to 10 and minus 10 to get like 2 points there, and so on and so forth. Otherwise, the formulas are pretty straightforward only. Yeah, and from a conceptual standpoint, right, you should be in a position where you know all the things that are required to crack. And we have seen many CAT questions also, right? So you would know from that standpoint that okay, what is the level of knowledge that CAT is expecting? Is CAT expecting me to know a lot of sophisticated stuff? Maybe 1 or 2 concepts or shortcuts that we covered reduce the time, but CAT does not expect you to sort of know like 100, advanced formulae, etc. Some shortcuts do help, but yeah, don't like orient your preparation, on based on those shortcuts, because that will harm immensely. So that is why we also discussed when we got to those specific points, right? So that is one thing, and the other thing is like keep in touch with geometry, because geometry, like unlike algebra and etc., right, where things are sort of easier to retain. Like once you study something like, for example, linear equation or inequalities, etc. Things are easier to retain. Geometry, because there are a lot of theorems and stuff that you need to keep in mind, it's always good to sort of have a weekly checkpoint in your self-study routine. That okay, let's say I'll take 5 to 10 questions of geometry, and then I'll go from there, so that you don't forget whatever is being covered. Right. For example, for like let's say small things, right? Cyclic quadrilateral we saw in our circus lecture yesterday, right? That the Ptolemy's theorem AC into BD we saw. But there was also a formula for AC by BD. Right. So that should also be in your mind that okay, I know this. So, and we've like the questions, I deliberately didn't keep like basic questions because I'm pretty sure that you guys would be well versed with it. I'm pretty sure you guys would know the fundamental concepts and theoretically as well. So all these questions were either intermediate or advanced, and of course some past CAT questions were covered across all the topics. And the other questions, even the non-CAT ones, were off CAT level, but from an intermediate and an advanced standpoint. So that you're sort of safeguarded, because again, going back to the statement yesterday, that 105% is safer than 98% for, especially for quant. Because one question can sort of take you from here to there. And one question, if you get wrong, then it definitely is a damage, because then you lose out on 4 marks, the 3 which you could have got from correct, and the one that is reduced from the negative side of it. So even for my paper, right, so I got 2 wrong, so otherwise the score would have been more by 2 marks, so the percentile would have been even higher, like the 88 would have gone to 90, and the percentile is improved. So that is why. But otherwise, it basically, like in terms of the concept, you should be well covered, right? And there, like so, like whenever you sit down for self-study from a geometry standpoint, next, just revise these questions once, revise the theory. You have the recording at your disposal. You know the concepts and all, and you can always go through them, and then you can take any source of questions that you want. I'm sure you would be like sort of giving mocks and stuff, etc. Let's say same cats, whatever. Especially same cats, because they sort of are a more better reflection of what you can expect, and you can analyze when you analyze mocks, or when you analyze like even past mocks and all. You can sit down with geometry, and hopefully you'll be able to cover many more questions now. Because concepts, we have covered everything that you need to know. Right. And in general, from an exam perspective, like, so again, being certain in VA and LRDI is difficult, because you don't know what questions can spring up. LRDI is still okay. If you practice a lot, you can be reasonably confident here that, okay, I like, let's say seating arrangements, I'm able to do quick. Team distribution based, or, let's say data, I'm good with data, so I can sort of do DI quicker than the average person does. VA, you cannot say anything. Quant is the only section where you can say with some level of certainty that if you prepare these topics, you will be able to score well. So one section needs to be your friend, right? So that for a lot of people is QA, because people inevitably end up spending more time in QA. But obviously VA and LRDI also have to be done daily, preferably daily, and QA needs to be like daily some practice, but like it is not necessary that you cover all topics daily. Like let's say you decide on algebra for, let's say, these 2 days I'll be doing algebra revision, these 2 days I'll be doing geometry revision, etc., etc. So that way you can plan your daily. But one section needs to be your friend, right? Otherwise, like the other section might just like take your score down significantly. In my case, that section was VA, so I was around 97ish in VA. LRDI was okay, I'm at 9.2, and QA was at 9.93. So the aggregate turned out to this. But essentially, one section needs to be your section of, okay, I'm comfortable in this section. Because, and with like my grad scores, etc., were not good. I'm talking like from a practical standpoint, right? And you would know that what is your position with respect to grad scores, or with respect to, your 10th and 12th, which were also not like optimal in my case. So I needed to score a high percentile, like there was no other choice. So yeah, so unfortunately, like things turned out okay. But otherwise, yeah, so just one section you need to be completely confident of, and LRDI again is sort of always the game changer in across all years. Person scoring high in LRDI will never fall back in terms of overall percentile, because as we discussed, that normalization will shoot that, catapult that person to a higher, even to an even higher level. So that's just good. But yeah, whenever you analyze your next mock, right, or you give your next mock, try to like see that if your thought process has improved in terms of approaching questions, or if your recall has improved, that okay, this is the question, this seems like, even if it doesn't seem completely familiar, it seems like something where this particular principle would work. Parallel lines, I can try similarity, right? These kind of circles, I can again try similarity, right? For triangles, I'm seeing medians, or like let's say angle bisectors and all. I know that 2:1 can be used. If I say angle bisector, we studied that ratio also, that can be used. So that should be sufficient. For cyclic quadrilateral, I know Ptolemy's theorem, I know I can be used for cyclic quadrilateral. In a circle, I know tangents and seconds are visible intersecting. I know that that can be applied. So these things, right? So these are sort of the major giveaways that should strike you even before you start like working on the problem, and you'll see that this reduces your time to do the question significantly, which is critical in terms of an exam type of a scenario. But okay, guys, once again, thank you for being fantastic audience to this. Really appreciate that. And uh, yeah, hopefully this did add some value and benefited. And again, feel free to reach out, you guys. Like obviously we have that WhatsApp group as well. You can always, ping doubts and stuff. So it's not like the workshop gets over, so the commitment gets over. You can ping your doubts and stuff as well there. If you're practicing and you cannot figure out certain questions. But that basically brings us to the end of our geometry workshop. So we're able to cover around 55 questions across topics. And again, the number is not important, but what is important that the variety has been okay. So hopefully it was worth the time, guys. And all the very best with your preparation.